advanced physics students. This video will cover section 8.3, the 4 fundamental forces. So there's a nice little table here that comes to us out of your textbook, and it kind of just gives us a pithy summary of each of the 4 forces and their relative strengths. We're going to look at the strong force first. The strong force is within an atomic nucleus, and it is responsible for holding the protons and neutrons together. It's pretty significant. And it is more than 100 times stronger than the electromagnetic force. It is also called a reciprocal attractive force. And what that means is there are quarks. We learned about this, I think, in chapter 2, if memory serves me. Quarks within protons and neutrons are actually attracted to one another by virtue of having opposite charges. This is a force, unlike the electromagnetic force or the gravitational force, that operates over a very, very short range. Let's look at the electromagnetic force. This is a force that only exists between electrically charged bodies. It is also a reciprocal force, but it may be either attractive between like charges, or it may be repulsive. I'm sorry. It's attractive between bodies of unlike charge, or repulsive between bodies of like charge. So, I mean, you guys all know this, that 2 positively charged objects are going to repel one another. But a positively charged object and a negatively charged object are going to be attracted to one another. So that's what that all means. The reciprocal nature of this and all the other forces is the basis of action-reaction force pairs. And as an example, if A repels B, there's an action, then B also repels A. There's the reaction. So unlike the strong force, which has a really tiny range, the electromagnetic force is unlimited in range, but it does diminish in proportion to the square of the distance between the 2 charged bodies. We're actually going to do some calculations. This is related to Coulomb's law, and we're going to do some calculations with this, probably coming up in quarter 4. So the electromagnetic force is responsible for holding electrons to the nucleus, and it is also responsible for the attraction between 2 molecules in close proximity to one another. As the 2 molecules get close to each other, the nucleus of the one molecule attracts the electrons from the adjacent molecule. And this plays a part in bonding or intermolecular interactions. So the electromagnetic force is responsible for the resistance of one atom's space to penetration by another, as the electron cloud, which is negatively charged in all these atoms or molecules, the electron cloud of one atom or molecule is a shield that repels the electron cloud of another. And this is what prevents, if you do a karate chop on your desk, it is this repulsion that keeps your hands from actually penetrating that desk. Next, we'll look at the weak force. So the mechanism of interaction between this is the mechanism of interaction between subatomic particles, and it is implicated in nuclear decay. This also operates over a very short range. And finally, we'll look at the gravitational force. This is the weakest in strength of all forces, and it exists between any 2 bodies of matter. It is a reciprocal attractive force only, producing no repulsion effects like the electromagnetic force does. And like the electromagnetic force, it diminishes in proportion to the square of the distance between the 2 bodies. And we'll be doing calculations with this as well, probably again coming up in quarter 4. So despite its weakness compared to the other forces, it is responsible for holding the moons, planets, and stars together in their orbits. The gravitational force is why we actually have a very beautiful moon out there. So that's all I had to say about this section. Very, very brief section. And section 8.4, addressing gravity and gravitation, will be yet another screencast. You guys have a great rest of the day.